So we are going to take what we've been doing with systems and we're going to apply it to a couple of word problems. I have two examples I want to take you through. In one of them, substitution makes more sense, and the other, elimination, makes more sense. So that's kind of a good balance for us. If you want to kind of jot them down, let me see if I can get them both. So there are two. Take a second, pause this if you need to. If you want to write them both down, if you'd rather write them as you go, whatever. I just basically divided my paper in half. That's why the second one starts underneath that second kind of punch. But it's up to you how you kind of want to organize it. But otherwise, we're going to be doing systems. I'm going to go in, just look at the top. Whoops, sorry. Go in, just look at the top one. So we can kind of get a good feel for that. There we go. Both of these problems came out of the book. The top one is kind of a blend of number 49 and number 50 from 7.1. And the bottom one's like number 52, I think, from 7.1. So they both come from 7.1 if you want to see them or see others like them. As we get going, I'm going to kind of keep track of some things that'll help us get this solved. So as I look at the first one, find the dimensions of a rectangle. So in other words, I got to find the length and the width with a perimeter of 220 and an area of 3,000 meters squared. One thing we should be mindful is of however many variables we have, that's how many equations. So the fact that we need to find length and width, and if you like this, so I call them base and height. I mean, rock on, whatever you want to call them. You can call them X and Y. But we need two equations. One of them we're going to get from perimeter, one of them we're going to get from area. So perimeter of a rectangle, right? So if we're thinking a rectangle, it's a lovely, lovely rectangle. We got a length and a width. I don't really care which one is which. And if you wanted to do base and height or X and Y, that's totally up to you, as long as you're keeping track. Perimeter says I have two W's and two L's equaling 220. Area says my width times my length equals 3,000. Okay? Now, we can't use elimination because our equations are different. One of them is adding and one of them is multiplying. So instead, here's what I'm going to do. First thing I'm going to do is I'm kind of going to ignore this left-hand side. And I'm just going to focus on, this is my first equation. And this is going to be my second equation. Right? Two equations, two unknowns. So here we go. Because elimination is out, I'm going to advocate for substitution. Here's how I'm going to do that. I'm going to solve for L. So the length is equal to this area divided by the width. And then I'm going to take that and substitute. 2W plus 2 times okay, so far so good. We've done substitution. We've plugged in what we have into where we're going, or into the other side. So the problem is I've got a W in the denominator. And so to get that W out of the denominator, I'm going to multiply by W here to cancel, by W here because I know that I've got to keep things all matchy-matchy, and W here. 2W squared plus 6,000 equals 220W. Okay? As we're going through this then, we now have a quadratic. And one of the key pieces of solving a quadratic is to make one side equal to 0. Whoops, excuse me. In order to do that, I'm going to bring that 220 over. I'm going to try to. by subtracting it. Now, this is where I would go to the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? Whatever you like is what you should use. This is factorable, but it's not easily recognizable that it's factorable, so I don't know that that's our best option right here. Granted, these numbers are huge, but we can get the results from quadratic formula. If you don't like quadratic formula, like I said, just take a second and plug it into Desmos or whatever you want, right? We could just plug this equation and look for the zeros. Lots of different ways to solve it. When we solve it, we find out two choices for W. So one of the choices is that W could be 50. The other choice is that W could be 60. Okay? And that feels weird, but it makes sense in a weird way, right? If W is 50, then L is 60. And if W is 60, then L is 50. So the moral of the story is, our final answer, the dimensions, this rectangle is 50 meters by 60 meters. Okay? So one quick example, let's look at the second one. Airplane flying with the wind from LA to New York City takes 3 hours and, nope, let me try that again. 3 3/4 hours, 3 hours and 45 minutes. Flying against the wind takes 4.4 hours. If the air distance is 2,500 miles, find the speed of the airplane and of the wind. So speed is going to be, in this problem, is going to be miles per hour, okay? So we've got with the wind, and we've got against the wind. Okay, so two equations, with and against. With the wind means that we've got our plane plus our wind. The wind is pushing the plane, it's increasing that speed. Against the wind means the wind is hurting us. It's counteracting what the plane is doing. Nice thing about this right now is that this looks beautiful to use elimination. The problem is we gotta get what's after the equal sign. Here's what we're gonna do. Because everything is in speed, we are going to calculate speed from the get-go. In other words, on the way there, the average speed, or the resultant speed, if we want to use our vector language, is 2,500 divided by 3.75. And on against the wind, we're going to divide by 4.4. Remember, speed is equal to miles per hour. Per means divide. So when I divide 2,500 by 3.75, I get 666.6 repeating. Wonderful. 2/3 is also a great way to do that. 2,500 divided by 4.4, right? It's taking us longer. Our speed should be slower. And then that 0.18 is repeating. If you want to use 0.7 and 0.2, I don't really care. Just know that this is what my calculator told me. Now, when I look at this problem, elimination, look at those W's. Those are going to go away. 2p equals approximately okay. Again, that 8.4 is technically repeating. but we're getting to the point now where we can start rounding. Divided by 2. So the speed of the plane is 617.42 miles per hour. Okay? The wind is either pushing us or kind of counteracting us. In the one where it's counteracting, we end up with a negative, so I'm just going to avoid that one, and I'm going to say, okay, 617.42 plus W so that if I want to find W, do a little work show in here. Whoops. Oh my gosh, sorry. There we go. We get the speed of the wind because we're just talking about in terms of speed. We're not talking about going with us or against us. I'm just going to keep it in the positive. 49.24. So final answers. The plane is about 617 miles per hour, and the wind is about 49 miles an hour. Probably should have units on there, feeling lazy. Go back, take a look at both of those. Biggest thing is, can you make the equations? Because I know you guys can do the math. You're rock stars.